Hi, this is the second video of the inequalities. In this video, we'll discuss about the Vivi method to solve the inequalities and plotting the numbers on the number line. The very first thing about the solution of inequalities, let me tell you about x minus 2 greater than equal is 0. X minus 2 is greater than 0 means x is greater than 2. It means x is taking all the values which are greater than 2. If I plot a number line, say this is 0, it says that x greater than 2 is the solution of this inequality. We have studied in the previous video also, right? Now, how to write the solution of this problem? It says that x is greater than 2. It means the writing way is x belongs to, this sign says belongs to 2 to infinity. All the values from 2 to infinity means x minus 2 is greater than 0. Here we use this small brackets. Now keep this in mind, keep this thing in your mind, when to use a small bracket and when to use the square bracket. Now had it been the equation be x minus 2 greater than or equal to 0, it means all the values including 2 and greater than 2 are the solution of this inequality, right? It says x is greater than or equal to 2. Now in this case, when we have to show that x includes the value of 2 also, so we say that x belongs to the square bracket 2 to infinity. So this is the difference in writing the solutions, and it's come with this difference in the inequality sign. So if it is a sign includes the value, given value, we include the value in this way, this square bracket, right? So this is the basic problem to writing the solutions and plotting on the number line. Let's take the more examples. If the problem is of the sort x minus 2 less than 0, we'll say that x belongs to minus infinity to 2, right? And if had it been this x minus 2 less than or equal to 0, means x belongs to minus infinity to minus x minus 2 to, and this bracket has to be square bracket because it includes the value 2 if now less than 0. Now in all the four cases, we have never used the closed bracket with the infinity, because infinity it's not the fixed value. We cannot approach, we can just approach to infinity. The exact infinity is not defined. Just say this small bracket in front of the infinity. While when we have the value, certain value fixed, yes, it includes the value 2 also, we include the bracket also, right? This is the way of writing a solution. And now had it been the problem is like x minus 2 into x minus 4 is greater than 0. Now, and it says that x minus 2 into x minus 4 is greater than 0. It means saying that x square minus 6x plus 8 is greater than 0. Now how to solve this kind of inequalities? For example, this is the inequality of the quadratic equation, inequations. This is a quadratic equation, and let's see how to solve it. First, we split into the factors, that is x minus 2 into x minus 4, which is greater than 0. Now solution, use this is 0, 1, 2, 3, 4, minus 1. To solve this inequality, we separately solve the critical points. We equate this thing equal to 0. The critical points is x equal to 2. We equate this as to 0, then it says that x equal to 4. We mark this critical point on a number line, say this is x is 2, and again we mark the critical point x equal to. Now the learning thing over here, we have marked this 2 and 4 here. Now assume the certain value which is less than 2, say 1. For the value 1, x minus 2, this is negative. For 1 minus 4, again negative. If you multiply the two negative quantities, the answer is positive. Yes, it is in our domain. Now if I take a certain value which is bigger than 4, let's say 5. If I take the 5 minus 2, positive quantity, that is 3. 5 minus 4, that is positive quantity, that is 1. Multiplying both the positive quantity, we get the answer as 4. If we take some value between 2 and 4, that is, let's say take value 3. For 3 minus 2, minus 1, and 3 minus 2 positive 1, and 3 minus 4 negative 1. So negative into positive, it gets the negative value. This is not in our domain, right? Now it says that all the values in this range gives a positive result, all the values in this range gives a negative result, and all the values beyond this will give again a positive result, right? So writing the solution, x belongs to, the positive one is till infinity, that will say infinity minus infinity. Obviously I will not include the square bracket here, up to 2, right? This is 2. 2 is not included because here is the only greater than sign. Here is the equality is not included. Now we got the solution, all solution between minus 2 to minus infinity to 2. Now we have solution between 4 to infinity. It says this is union. Union means including the solution 4 to. So this gives the solution of this inequality. This way we represent the solution, and in this way we represent in the number line, right? If same problem is like x minus 2, x minus 4 is less than equal to 0. It means I'm saying that x square minus 6x plus 8 is less than equal to 0, right? Now again we have split it into the factors. These are the factors. We've noted down the critical point, that is x equal to 2 and x equal to 4. Critical points, again I'm telling you, is getting by the marking the values, individual values to 0, right? These are the critical points. Again I'm drawing the number line. X equal to 2 is a critical value. X equal to 4 is again a critical. So obviously less than 2 value will give the positive. This is minus then positive. So remember, every time we start with from the back end, that is from the left hand side, we start marking positive, then negative, then positive. So remember this thing. So the writing solution is, because we have the range of less than 0, means we are talking about this negative thing, because it's less than 0. Therefore the solution is x belongs to 2 to 4, right? And now 2 and 4 are also included because it gives the inequality signs. So we change the bracket here, we make this bracket as a square bracket. So the solution of this inequality is x belongs from 2 to 4, and 2 and 4 are included. And this is the way to write the solution. Next thing is, say if this equation becomes x minus 2, x minus 3, and let's say x plus 2. If I ask you find the solution x minus 2 into x minus 3 into x plus 2 greater than 0. Obviously if we all multiply this, we get a cubic equation. Sometimes cubic equation is given, we have to split into these factors. Let me teach you the how to solve inequalities. If x minus 2, x minus 3 and x plus 2, if we separately equate to 0, x minus 2 equal to 0, it gives a critical point 2, it gives a critical point 3, it gives a critical point minus. Again the first step is plot the number line. So this is 0, 1, 2, 3, minus 1, minus 2. Now plot these critical points on the number line. First is 2, then 3, then minus 2. Now we got range from this, then this from this. Again we do the same thing. We start from the left hand side, we start marking the positive, negative, positive, and then negative. We have marked down the point. Now we check the problem is of greater than 0. It means all solution which has a positive sign is the solution of this inequality. Now let's write the solution here. X belongs to minus infinity to 2, right? To 2. Then we close the bracket. Now here the closing bracket would be a small bracket or square bracket. Obviously it's a square bracket. Obviously it's a square bracket because it gives a sign of equality also. So this is square bracket, then union, then again a square bracket, that is 2 to 3. This is a solution of this inequality, right? What if, so what is the solution for the inequality x minus 2, x minus 3 and x plus 2 less than 0? If I solve this thing, means the domain points are negative 1, this is less than 0, here is not the inequality. We make the solution as x belongs to, we start from the left hand side, this is positive, we will not take it, this is negative, we include this minus 2 to 2, both have the small bracket because values are not included, because here is a, it's not the sign of equality here. Then union 3 to in. So for this equation solution is this, for this the solution is this. Right. Next, another important thing while solving this equation is, if the equation is like x minus 1, x minus 2 upon x minus 3. Again there is same method. If it is in the division, if it is in multiplication, doesn't matter. Again we plot the number line 0, 1, 2 and 3. Here is the positive sign. Again we mark the critical points. X minus 1 equal to 0. Critical point from here is 1. Critical point from here is 2. Critical point from here is 3. We mark the point 1, 2 and 3. Now it's greater than sign. We mark the reasons. This is positive, then negative, then positive, then negative. Now here the sign is positive. Solution is of course x belongs to minus infinity 2, 1, then union. This is negative, we left it, then 2, 2, 3. This is solution, right? Now, the important point over here is, if had it been the solution included here B, if solution B, if the equation might have the sign this x greater than or equal to 0, right? The solution will become, obviously the number line is same. Here we write the solution x belongs to minus infinity to 1. Obviously we include this bracket here, greater than sign, union 2 to 3. Now the thing is, here 3 is in denominator. If x is equal to 3, this value is not defined, because x cannot be 3, because denominator cannot be 0. So we will not include the 3, just include the 2. This is the right solution, will not include the 3. So whenever you have the denominator value going to 0, will not include that value, because denominator 0 is not defined. So whenever we have the critical points in the denominator, will not include that points. Therefore we have not included this point. This thing will always be a close bracket or small bracket, open bracket. Next, solution of the quantity x square plus 1 into x minus 2 into x plus 3 less than 0. Now again we mark the critical points. Here the critical point is 2, here the critical point is minus 3. What about this? This quantity cannot be 0. X square plus 1 equal to 0 is not possible. For all the values of x, whether negative or positive, this quantity x square is positive, and again 1 is positive. So if we add two positive quantities, we will never get the value 0. So this never be the positive 0. Now if we put any value of the x, positive or negative, this thing become positive, and positive plus 1 is always positive. We'll say this always remain positive, right? We have learned that multiplying any positive quantity to the equation will not change. So now this equation will turn up like this: x minus 2 into x plus 3 is less than 0. Right? Now we can write the solution: this x minus 2 to plus 3 is less than 0. Therefore the solution is minus 3 to 2. If we plot the number line, minus 3 and this is 2, this is positive, this is negative, and again this is positive. So the required range is minus 3 to 2. So always remember the critical things. First, check the denominator. If it is denominator cannot be 0. Second thing, whether the quantity is already a positive 1. So we'll eliminate that positive quantity and solve the remaining problem. Find the solution of the equation: x square plus 1 into x square plus x plus 1 less than 0. Now x square plus 1, this is always be a positive quantity. If it's x square plus x plus 1, if we check the d, that is discriminant of this quadratic equation, is negative. So this does not have any positive roots, and of course if this quantity is greater than the value of coefficient of x square is positive, so the value of this expression is always positive. If we draw the graph of this is something above the x-axis, the value of this expression is always positive. This is positive, this is positive. Multiplying the two positive quantity will always get a positive quantity. Therefore this quantity can never be a negative one. So the solution here is x belongs to 5. That is null set. There is no value which is satisfy this quantity, right? Next question: x square plus 1, x square minus x upon x square plus x plus 1, x and x minus 1 is less than 0. If we solve this problem, again we mark the critical points here. Critical points here is this quantity is positive, no critical points. Critical points here: x square minus x. Critical points are 0 and 1. 1 x equal to 0, it becomes 0, and for 1 this is 0. This quantity is always positive. Let's make this less than or equal to 0. This is 0 and this is 1. Right? Now let's plot these critical points. The critical points are 0 and 1. 0 and 1 for less than or equal to 0. For this quantity also 0 and 1. These are the four critical points. 2 are same, 2 are again same. Now if we imagine the positive and negative points, let's say this is positive. Again the value between 0 and 0 is negative, which is nothing, then positive, then negative, then positive. Here we see that for all the values this is positive except 0 and 1. Because between something 0 and 0 there is nothing quantity where it is negative, and again it's a negative one. So this is a very important example here. X cannot be 0 because it's a denominator, and x cannot be 1 because again it is into the denominator. So we say the solution of this is x belongs to 5. There is no solution of this equation because for every value it is positive except the value 0 and 1. For 0 and 1 it is not defined, right? So the solution is x belongs to 5, and there is no solution of this quantity. Had it been the problem be x is greater than equal to 0, had it been the problem is x greater than equal to 0, it means the value is equating value, right? So the solution for this, x belongs to real numbers, any value minus 0 and 1, will not include the value 0 and 1 because it is the denominator. Moreover, you analyze the problem, this is x square minus x, this is also x square minus x, we can cancel out, but we are not, before cancelling, mark the critical points also because that are important into the problems, right? You can cancel the things but mark the critical points and then solve the problem again. Mark the critical points and set that the value is in the denominator is 0 or not. This is a good example of solving the problem. Thank you and have a nice day.